Welcome back everyone. Let's have another tutorial on Femap, and now we're gonna start developing our knowledge about meshes. Let's take a look at this example that we worked on earlier in these tutorial series. We did this I-beam, right? If you haven't watched this video, make sure you go back and watch it, and you will see that why did we have mesh issues. This one, and we meshed it and ran the analysis with some loads. I believe we had a pressure on top of it, and then the result came out this way. The top simply just ripped through the vertical part and the bottom like magic, and simply just bent, and it's just nonsense. It's complete garbage. So now we're gonna start working on analyzing and setting up meshes the right way so this kind of chaos doesn't happen. So if we put it back in place, let's see what was the problem. So when elements meet these, if you push Ctrl Q, go to labels, you can visualize the identity of elements. See, each element has an identity number. Click OK, and let's see. So we have a vertical and we have a horizontal piece here, and when the two come and meet, the nodes are not associated with each other at all. The bottom plate has 1, 2, and 3 elements. You see, this piece and this piece is not two different elements, it's one. Number 30. And the nodes for it is here, 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 and here. The horizontal plate has absolutely no nodes here or here. The vertical one, as it comes down, has nodes here and here, but those are absolutely have nothing to do with the vertical plate. They are not connected in any shape or form. That's why we have the same thing along the whole edge down there. Up here, the same story is happening. That is why when we ran the simulation, the top plate simply just crashed through everything because it wasn't in its way. They were not connected. They don't even know about each other. Okay, so things like this we need to make sure we catch and fix before we run a simulation, so our results are realistic, because otherwise we would just get garbage like this. This was a great example to start and practice things, but now we're getting a bit more professional, so we need to make sure we do things more accurate and correct. Okay, let's get started. Okay, we're gonna practice on these 4 little models right here. If you don't know how to create them, it's okay, just watch the video and understand the concept, and I'm pretty sure you'll be able to transfer the concepts from what you see here to whatever geometry you are trying to work on. Okay, so let's practice making our meshes better. First up, let's take a look at our free edges. All these surfaces have edges, right? Free edges, which simply means the perimetral edges. Some will cause problems, some will not. Like here on our first, most likely we will have some problem. And out of all of these edges, which one will give us a problem? Here, here, and here, they are free edges that do not intersect anything else, right? Here, here, and here, again, there's no problem. But the surface number 1 has an edge here that is shared or is in common with surface number 2, and surface 2 has its own free edge here. So there on this line there's 2 edges. One belongs to this guy, one belongs to this guy, and they are not joined together. And if we run our mesh, then we're gonna have issues. So something like this we need to fix. So let's visualize our free edges. If we go to meshing, and right here we have the first 2 buttons, click on the second one, this window down, and right here toggle entity locator, turn it on, this window will open, and we can find free edges right here. If you click on it, all the edges will be highlighted in whatever geometry you're working on with a nice and yellow.
And if you want to get rid of them, don't want to see it anymore, just push Control G and it'll regenerate. Right here you can confirm it in the text window. Great. There you go. Regenerate, and see, they're all gone. Okay. Let's take a quick look what happens if we mesh these with different size meshes. Mesh control, size on surface, pick one. Okay, let's leave this one with the default that it gives, 0.166. Okay, and then click this one. Okay, but this one I'm gonna mesh with something bigger, let's say 0.2. Okay, so as we can tell, we're gonna have different element sizes here. See over here, you can see the seeding marks. We're gonna have more elements in this one than in this one because they are different sizes, right? So let's go ahead and where is it? Mesh control and no, geometry and surface. I'm gonna mesh this one. Okay. Property. Oh, we didn't define anything, so it's okay. Just doesn't matter what size or tri or quad. Just leave it as is. There you go. Let's do the other one. Geometry, surface. Pick the two. Okay. Let's leave it as is. Okay. There you go. So if we zoom in, what do you see? Again, just like we saw here. See, they're not matching. This node is not matched with that. That is not matched with that. Same thing happening here. See, not aligned. They are not matching. So these are not connected. This is a cracked mesh. And also, that's not even just the only problem. If we push Ctrl Q and visualize our nodes, we can see that even the ones that do align, like here at the corners, they're duplicates. See, there's two numbers written on top of each other, is because there's two nodes there with different identities. One node belonging up here, one node belonging down here. Okay. And another way to show free edges, instead of the locator, close that one, go down to mesh sizing, and right here at the bottom, show free edges. If you check that, there you go, you can see that again, all the nodes. Okay, let's get rid of all this stuff that we created here. I'm gonna go to delete, geometry, model, and mesh. Oh, select all. Okay, yes, the mesh is gone. The seeds are still here, so we can go to mesh, control, size along curve, select all. Okay, and instead of seeding it, we can push this button right here, the reset. There you go, and see all the seeds and all the stuff that we created, it's gone. We're back to the original. So one method to solve problematic mesh creation is stitching. So we're gonna stitch these two surfaces. So go to geometry, solid, stitch. We're gonna pick the two surfaces, click OK, and this is gap tolerance. So if you have some big geometry and you have hundreds of edges, what it's gonna do it's gonna take your gap tolerance that let's say you're gonna put here 2e negative 3, and it's gonna search every single edge, free edges that you have, and it's gonna see is it more or less than this, and if it's this much, it's gonna go ahead and stitch it, this or less, right? So click OK, and there you go, the free edge is gone. So free edges we have out here now, which are not problematic, they are not connected to anything, those are fine, they will not cause any headaches. So let's go ahead and do the same thing what we did before, Control G, so we don't see the free edges. We're gonna go ahead and mesh, control mesh, size on surface. I'm gonna pick this one. Okay, I'll leave the original one. Okay, I'll pick this one. Okay, I'm gonna mesh this with something bigger, 0.2. So again, we have two different meshes, right here and here. Let's go ahead and perform the mesh on surface, this and this. Okay, just leave as is. Okay, there you have it. So but now what do we see? If we put Control Q, visualize our elements and nodes, okay, we can see that he was smart enough to know that these two are connected, they are stitched, and therefore even though the mesh sizes are different at the top and bottom, he did not mess up the meshes. The nodes are coincident, right? And also we can see the identities 1, 2, 3, and there's no duplicates. There's no two numbers written on top of each other. So this mesh will not give us any problem anymore. Let's try the same process here, but in this little setup over here we have an issue. Stitching will not work as is because we only have two surfaces. We do not have uh, two free common edges over here. This surface's edge is just sitting in the middle of this one. This one does not have an edge going across here. As we can see, there's only two identities, 3 and 4, right? 3 is the vertical, 4 is the bottom. So stitching would not work as is, so we need to partition the bottom one in half. We can go to geometry, solid, slice. We're gonna slice, let's see, with a curve, and we're gonna click OK. We're gonna select the solid we want to slice. That's gonna be this one. Okay, what curve do we want to slice with? We're gonna slice with this one. Click OK. And what direction do we want to slice? So it's gonna be in the Y direction, so click Y axis right there. See, Y and negative. There you go. See, good. Click OK. And if we check our identities right now, we can see that there's three surfaces, right? 3, 4, and 15. Okay, now we can proceed with our stitching. So go geometry, solid, stitch. I'm gonna pick this, this, and this, all three of them. Okay, pick some small tolerance, 1.2. I mean something a little bit bigger than -6. Your depends how your drawing is. I'm gonna pick -3, 1.2 e -3. Okay, and there you go. And okay, so it did stitch it, and some versions of the Femap software has a bug in them where even though it did stitch it, it will still highlight it as a free edge. So just keep that in mind. But you can check that by performing your mesh and visually actually checking it to make sure that your mesh came out congruent. Okay, so let's go ahead and seed our meshes. Size on surface, I'm gonna mesh every single surface, all three, with different sizes, just so make sure that they are not accidentally falling in the same place. Okay, so 0.166, I'm gonna take this one, 0.125, what did 166? Oh, okay, so let's put 1.2, and this one 1.0.3. There you go. Cancel, and now they are seeded differently, so there's no way these nodes will align automatically. So we can go back, mesh, geometry, surface, select all three. Okay, okay, okay. And if we wanna check, there you go. You can tell that even though sizes are different, our mesh is congruent. The nodes are aligned nicely, and there are no duplicate nodes even down here, right? Perfect. So this will not give us headaches with meshing. So there you have it. If you would have done, let's do Control Z, take off the mesh. If you would do, let's say, geometry, surface, and you mesh them one by one. Okay, okay, okay. Then let's do mesh surface, this one. Okay, okay, okay. And geometry surface, this one. Okay, okay, okay. Whew. Okay, so exact same thing happens. It's able to figure out and make it congruent, but what do you see? We have nodes that are not, what is it? We have duplicate nodes. Whoa. We have duplicate nodes. So it did not realize to put it in into all these connections, make it on top of one. But it's easy to fix if you somehow ended up with this one. Go to file, no file, tools. Where is it? Oh, click this down, check. Click check and coincident nodes. There you go. Check, select nodes. Let's go to pick, box, pick, and I'm gonna simply box pick all of these. Okay, put some small tolerance and click OK. And let's take a look. Our duplicate nodes are fixed. Now you can nicely read every single one. All right. Alright, so we pretty much learned everything that needs to be learned, so let's do a little practice. With these two, we'll see a little difference here, but it'll be the same thing what we just did, and all we're doing is practicing now. So let's take this one and do seeding with different sizes on all of them. Size on surface, and let's see this one. Okay, leave this as default. Alright, let's pick this guy now. Okay, let's 0.19. Okay, this one 0.2. This one, let's see, 0.22. And this one 0.25. There you go. Every single surface has a different mesh, and this can happen in any kind of model that you're working with, because if you're working with an airplane, a car, whatever, some parts we are more interested in what's happening than in other parts. If some stress is happening here, we want to mesh this super fine and make sure we see it as accurate as possible to what's going on. But if absolutely nothing's happening in other areas, you just want to see maybe how it propagates there, you can kind of relax and reduce your elements as you go away from the center of attention, right? Okay, so mesh, geometry, surface. Let's pick all 5 of these. Okay, leave these as is, or you can even change it. We had quad, let's do this one with triangular ones. Okay, and there you have it. Let's verify, do we have any issues? Yep, we do have issues, right? There you go, duplicate meshes, unaligned, not congruent meshes. So this is garbage. This would give us a lot of headaches. So Control Z, get rid of those. Let's go ahead and stitch it. Solid, stitch, where's stitch? There you go, stitch. So let's take this, and this. Okay, let's make something small, something a little bit bigger than that. 1.2 e -3. Okay, there you go. Now it shows that the new free edges are out here, and in here there's no more free edges. Very good. Now we can go back to mesh, geometry, surface. Let's pick all of these. Okay, did leave a triangular one. Okay, okay, there you go. Let's see now. Let's see. There you go. Congruent meshes, no duplicate nodes. Everything seems to be in order. Very good. There you go. Doesn't matter that we had 5 different sizes, big one, small one, whatever, it figures it out. Good. Okay, let's go to the last one. So
as you can tell, it's always asking for a tolerance, right? Because when we draw stuff or import from other SolidWorks or CATIA or whatever, yeah, you can have tolerances between surfaces that are not the same, one bigger, one smaller. This one we are exaggerating it quite well, so actually we can see a difference. If I would make 0.003 difference, you would not see it. So we're just trying to make a case for it. In order to know the distance between these two, let's go to Tools, Measure, Distance. So let's see, pick this point, okay, this point, okay, and it's gonna give us the distance. Cancel that out. There it is, 0.121356.9. Okay, so there's your distance. So whenever we gonna stitch, we need to make sure that our tolerance is bigger than this, or otherwise it will disregard it. So let's go to Geometry, Solid, Stitch. We're gonna pick this, and this. Click OK. Here it is, tolerance. So see here, it is E negative 6. That will completely disregard this one. This is way bigger than that. So make sure that we put something bigger than this. So I'm going to put 0.15. 0.15. Make sure it understands that I want to include this. Okay, and there you go. It blended it. It visually looks ridiculous, right? But it handled it. It took care of it. And we can see that there's no more free edges in there. Okay, so let's go ahead, do some meshing, mesh control, size on surface. This one, let's make this one huge now, and the other one small. So 0.3, and make these other ones smaller. So leave that one, this one 0.17. Okay, this one 0.18. This one, let's make this super fine, 0.0. I'm curious how that's gonna come out. 0.05. Let's take a look. See, we have ridiculous differences in size. Wow, I'm curious how that's gonna go. Let's see. Cancel it out. We are done with that. Model, mesh, geometry, surface. Pick all of them. Okay. Let's do quads this time. Okay. Okay. And there you have it. Let's turn off the geometry and have only the mesh visible. There you go. It was able to blend these giant elements with the tiny ones. See, that's what it does. It has a kind of like a buffer area. We start with these giant ones, and as we blend toward the smaller and smaller ones, it gradually forcing it to reduce the size to what you specified, right? So there you have it. See, small, giant, and other measures. And also we can see, right, congruent mesh, no duplicate nodes, and ridiculous gap between the plates. Alrighty, well, that would do it for this tutorial. Hope you guys enjoyed it, and make sure you tune in for the next probably I would say 3 episodes that we're gonna have on meshing. This was stitching, and then we're gonna have 3 other methods where we can make sure we have meshes that cooperate and do a good job for us. Thank you for watching. Like the video, subscribe, and have a great day.